Hello, welcome. This is a video just to solve an example in chapter 3. And so we'll just go straight into that. So we already know what a contingency table is. So we have this example here. And so it's a statistics class reports that the following data on gender and then eye color for students in the class. So when you look at this table here, this is the eye color. The eye color we have brown, blue, brown, green, hazel, or other. Then these are their totals. Then gender, we have male and then female. So now let's try to answer the questions. Now, the first question is that, a minute. So the first question is that, what percent of females are brown eye? What percent of females are brown eye? So now we want to know, how many females do we have? What percent of females are brown eyes? So we want to know how many females do we have? So we have what? 32 females. So that is our denominator. How many of them are brown eye? How many of the females are brown eye? That is 16. And so that is what? 50%. Let's get to the next question. What percent of brown-eyed students are female? What percent of brown-eyed students are female? How many brown-eyed students do we have? When we look at this, we have what? 36 brown-eyed students. How many of them are female? 16. That represents 44.4%. Are we all okay? Do you have any questions? Okay, let's get to the next one. What percent of students are brown-eyed females? What percent of students are brown-eyed female? What percent of students? How many students do we have? We have 64 students. How many of them are brown-eyed female? 16 brown-eyed female. What is 16 out of 64? That is 25%. The next thing we want to do is to compute what is the distribution of eye color. So now we are trying to find the marginal distribution of eye color. So to find the marginal distribution of eye color, all we want to do is to find that. So let's do, how many eye colors do we have? We have blue, brown, we have green, hazel, or other. Okay. And so how many people are blue-eyed? So that is going to be what? 10 over 64. So 10 out of 64 represent 15.6%. How many of them are brown eye color? That is going to be what? 36 over 64. And that represents 56.3%. How many of them are green or hazel? 18 over 64. And then that represents 28.1%. Now we want to find what is the conditional distribution. What is the conditional distribution of eye color for males? What is the conditional distribution of eye color for males. Now let's get to our table here. So you see we are looking at this side. The conditional distribution of eye color for males. We are looking at this side. And so how many males do we have? We have 32 males. And so to do that, conditional distribution, so let me put this one here, the answer for 5. So we should also have, how many eye colors do we have? We have blue. So for blue, brown, hazel or green, or other. So we are looking for what the conditional distribution of eye color for males. Males. So we are just focusing on this rule here. So total number of males is what? 32. So for blue, we have 6 over 32. Six over 32, which represents 18.8%. For brown, 20 over 32, which represents 62.5%. And also for hazel, we have 6 over 32, which represents also 18.8%. You see, now we want to answer 6. Compare the percent who are female. Compare the percent who are female among blue-eyed students to the percent of all students who are females, who are female. So we are trying to compare the percent of students who are females among blue-eyed students, right? Compare the percent who are female among blue-eyed students. Okay? So compare the percent of female among blue-eyed students. So let's look at that. How many blue-eyed students do we have? We have 10. How many of them are female? 4. So we have 4 over 10, which is 40% of, so 40% of female who are blue-eyed students. And then we are trying to compare it to the percent of all students who are female. How many students do we have? We have 64. How many of them are females? The females is what? 32. So that's going to be what? 32 over 64, which is equal to 50%. So we see that 50% of all students are female. And then let's answer the last one. The last one is question 7. So it's saying that does it seem that eye color and gender have an association? Does it seem that eye color and gender have an association? Let's try to do that. So eye color and gender has an association. So you can see, so you can try to compare male. So you can see that 6 out of 10%, 6 out of the 10 people, or for the blue-eyed people, are males. We can also see that 20 out of the 36 people of brown eye color people are males. you can also see that 6 out of the 18 people, 6 out of the 18 people who have green, hazel, or other eyes are males. I repeat again. So to be able to do that, we can see that 6 out of the 10, let me use a different color. Let me use blue. So 6 out of the 10 people who have blue eyes are male. We can also see that 20 out of the 36 people who have brown eye color are males. We can also see that 6 out of the 18 people whose eye color are green, hazel, and others are male. And so when you find the ratios across this, when you find 6 over 10, 20 over 36, 6 over 18, you can see that they are different. And so we can conclude that yes, there is an association between eye color and then gender. Okay, let's try to also, so now look at this table here. Let's open StatCrunch and then input this table there and try to get the contingency table. And then also let's do some split bar charts, split bars, and then also stack. And then let's try to see how it also looks like. Remember, you can also use those split bar graphs to give you a sense of you see whether there's an association or not. So let's try to do that. So let's get to StatCrunch. So this is our StatCrunch for the previous one. So let's do for this new one. Um, Let me see if I could be able to delete all this. Okay, good. So let me put gender here. Gender. Let me put blue eye, brown, green, hazel, or other. Nicely. And gender, what do we have? We have male, we have female. And then 6, 4, we have 20, 16, we have 6, and then also 12. You don't need to put in the totals because StatCrunch can compute the total. So this is our table that we had. Now, let's try to get the contingency table. So we come here, you see we go to table, contingency table with summary. What is the column? Our column is what? Blue eye, brown eye, hazel. And then our row label is gender. I want to compute row percent, column percent, and percent of total. So we hit that. And then there we go. Compute it for us nicely. You see, you can cross-check with the totals. So we had 64 students, and you can see. And then that's the row total. So you see, it's telling you here, row, column, and percent of total. So you see, this is row, column, and is the percent of the total. So you just need to know that. Let's try to also draw the split. So I come to graph, I go to columns, and I have blue, brown, hazel. I do gender. What do I want? I want vertical bar splits. I hit compute nicely. You see, nice one. We could also do stack, could do edit. We could do, so remember if you do horizontal bar split, you see how it looks like, but I don't like that. But if you want it, you can do that. I want vertical bars stacked and then nicely. So that is also how to display that. That is all for this example. I'll see you in chapter 4. Have a good one.